GCP Platform and Cloud Engineering Part 5. This episode has 16 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. API or auth? What is the difference between authentication and authorization? Here's a strong way to approach it. Authentication answers, who are you? Authorization answers, what are you allowed to do? For example, a user may authenticate successfully with a valid token, but still not be authorized to delete a production resource. In API design, I first validate identity, then check roles, scopes, groups, tenant ownership, or resource-level permissions before allowing the operation. Nice, let's continue. Question 2. API or auth? How do JWT tokens work in API authentication? Here's a strong way to approach it. A JWT is a signed token containing claims such as subject, issuer, audience, expiry, scopes, and roles. The API validates the token's signature using a shared secret or public key, checks expiry, issuer, and audience, and then uses claims for identity and authorization decisions. JWTs are useful because services can validate tokens without calling the identity provider every time, but they must be short-lived, properly verified, and never trusted without checking signature and claims. Great, moving on. Question 3. API or auth? How would you implement role-based access control for APIs? Here's a strong way to approach it. I would define roles or scopes based on business operations, not just technical endpoints. For example, viewer can read, operator can trigger approved actions, and admin can manage configuration. In the API, authorization middleware or dependencies should check the caller's role, scope, tenant, and resource ownership. For sensitive operations, I may require additional approval, audit logging, or break glass workflows. I would also test authorization paths because broken access control is one of the most common API risks. Alright, next question. Question 4. API or database? How do you handle database transactions in API development? Here's a strong way to approach it. A transaction groups related database changes so they either all succeed or all roll back. For example, when creating an order and reducing inventory, both changes should be committed together or not at all. In API code, I keep transactions short, avoid long external calls inside transactions, handle rollback on exceptions, and design idempotency for retry scenarios. For distributed systems, I avoid pretending one database transaction can cover every external service. Instead, I use outbox patterns, queues, or compensating actions. Let's keep going. Question 5. API or error handling? How should an API handle errors and return error responses? Here's a strong way to approach it. An API should return consistent error responses with status code, error code, message, and optional correlation ID. Validation errors should tell the client what field is wrong. Authentication and authorization errors should be clear but not leak sensitive details. Server errors should not expose stack traces. Internally, the API should log enough context for debugging, including trace ID, root, status, dependency, and exception type. Good error handling improves both client experience and incident response. On to the next one. Question 6. API or versioning? How do you handle API versioning without breaking existing clients? Here's a strong way to approach it. I avoid breaking changes where possible. For breaking changes, I use versioning such as or v1 and or v2 paths, headers, or media types depending on the platform standard. I keep old versions running during a deprecation window, communicate migration timelines, and monitor usage by client. Additive changes like adding optional fields are usually safe. Removing fields, changing meaning, changing required fields, or changing status codes can break clients, so those require versioning and coordination. Good, here's another one. Question 7. API or pagination? How would you implement pagination, filtering, and sorting in an API? Here's a strong way to approach it. For pagination, I can use limit and offset for simple cases, but cursor-based pagination is better for large or frequently changing datasets. Filtering should allow approved fields only, such as status, date range, owner, or region. Sorting should also whitelist allowed fields to avoid unsafe queries. I would define max page size, return metadata such as next cursor, and ensure database indexes support common filter and sort patterns. Nice. Let's continue. Question 8. API or idempotency. What is idempotency in APIs and why is it important? Here's a strong way to approach it. Idempotency means repeating the same request produces the same result without duplicate side effects. Get, put, and delete are generally expected to be idempotent. Post is not automatically idempotent, so for payment, order, or automation trigger APIs, I would use an idempotency key. This matters because clients retry after timeouts, networks fail, and gateways can resend requests. Without idempotency, retries can create duplicate orders, duplicate jobs, or unsafe repeated actions. Great. Moving on. Question 9. API or rate limiting. How would you implement rate limiting and throttling for APIs? Here's a strong way to approach it. I would usually implement rate limiting at the API gateway, ingress, load balancer, or service mesh layer, and sometimes in the application for tenant-specific rules. Common strategies include fixed window, sliding window, token bucket, and leaky bucket. I would return 429 when limits are exceeded and include retry information where appropriate. Rate limiting protects the API from abuse, runaway clients, and noisy tenants, but limits should be based on real capacity and business needs. Alright, next question. Question 10. API or security. What API security best practices would you follow in production? Here's a strong way to approach it. I would enforce HTTPS, strong authentication, authorization, input validation, output encoding where needed, rate limiting, secure cores, safe error responses, dependency scanning, secret management, audit logging, and least privilege access to databases and cloud services. I would also protect against common risks such as broken access control, injection, excessive data exposure, SSRF, insecure direct object references, and sensitive data in logs. Security should be handled at both gateway and application layers. Let's keep going. Question 11. API or testing. How would you test APIs before releasing them to production? Here's a strong way to approach it. I would test APIs at multiple levels. Unit tests for business logic, integration tests with database or dependencies, contract tests for request or response compatibility, authentication and authorization tests, validation tests, negative tests, performance or load tests, and security checks. I would also test migration compatibility and rollback behavior. In CI or CD, tests should run automatically on pull requests, and production deployments should include smoke tests and health checks. On to the next one. Question 12. API or documentation. How do you document APIs for front-end teams and external consumers? Here's a strong way to approach it. I document APIs using OpenAPI or Swagger with endpoint descriptions, request and response schemas, status codes, error formats, authentication requirements, examples, pagination rules, rate limits, and versioning policy. Documentation should be generated from code where possible but still reviewed for clarity. For external consumers, I would also provide onboarding notes, sample curl commands, SDK examples if needed, and a changelog. Good. Here's another one. Question 13. API or observability. What logs, metrics, and traces would you add to a production API? Here's a strong way to approach it. For logs, I would add structured JSON logs with request ID, trace ID, method, root, status code, latency, user or tenant ID when safe, dependency name, and error type. For metrics, I would track request count, error rate, page 95 and page 99 latency, saturation, database latency, dependency failures, and rate limit events. For traces, I would instrument inbound requests, database calls, external API calls, queue publishing, and important business operations. Correlation IDs make debugging across services much faster. Nice. Let's continue. Question 14. API or performance. How would you improve API performance and reduce latency? Here's a strong way to approach it. I would start by measuring latency by root and dependency, then identify whether the bottleneck is application CPU, database queries, external API calls, network, serialization, or cold starts. Fixes may include indexing queries, connection pooling, caching, async I/O for suitable workloads, reducing payload size, pagination, avoiding N+1 queries, tuning worker count, and moving slow work to background jobs. I would validate improvements with load testing and production metrics. Great. Moving on. Question 15. API or scalability. How would you design an API to handle high traffic? Here's a strong way to approach it. I would design for horizontal scaling with stateless API instances behind a load balancer, auto scaling based on CPU, latency, or request rate, connection pooling, caching, rate limiting, and resilient dependency handling. I would use queues for long-running or bursty work, circuit breakers or timeouts for downstream services, and database scaling strategies such as read replicas, indexes, partitioning, or caching. Observability and capacity testing are critical because scaling the API alone does not help if the database is the bottleneck. Alright, next question. Question 16. API or deployment. How would you deploy an API using Docker and Kubernetes? Here's a strong way to approach it. I would build a minimal Docker image, run as a non-root user, configure the app through environment variables or mounted secrets, and expose the application port. In Kubernetes, I would create a deployment, service, config map, secret, readiness and liveness probes, resource requests and limits, HPA, and ingress or gateway routing. I would use immutable image tags, rolling or canary deployments, monitor error rate and latency after rollout, and keep rollback available. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.